Okay, in Module 5, Lesson 7. Now, I know this said they wanted you to draw 3 different ways that they can make boxes. Well, I'm not going to grade you on how you can draw a box. So what I want you to do is I showed them today a factor tree. And that's what I want you to show in the boxes. So I'm going to, there's many answers. And I'm going to show you just one of them. Well, I'll show you 3 of them. Basically it said that it wanted 60 cubic inches. Okay. Well, if you do a factor tree, I'm going to look for 2 factors of 60. And I know that'd be 6 times 10. Well, now that's 2 factors. But I want in a 3-dimensional shape, so I need 3 of them. So now I'm going to break the second factor down to 2 times 5. So as you can see, I have 6, 2, and 5. So if I have the dimension 6 times 2 times 5, I know 5 times 2 is 10, times 6 is 60. So that's one of the sizes. And I could say it anyway. I could say this is my length, this is my width, and this is my height. Now another one. Let's come over here, 60 inches a third. Now, I had 6 and 10 before, but I haven't exhausted that yet because I know 6 I could do 2 times 3. So as you can see now I have 3 dimensions again. And I can go 2 times 3 times 10. 2 times 3 is 6. 6 times 10 is 10. So once again I could label length, height, width, however I wanted to put them. On C, I'm going to do one more time, 60 inch cubed. Now this time I could do a couple different ones, but this time I'm going to go 20 times 3. That gives me 60. And it can be any 2 factors that when you multiply them together equal the product that you started with. Now I'm going to take the 20. Now I'm going to go 2 times 10. So there's my 3. Now I'm doing 2 times 10 times 3. So my length was 2, my width is 10, and my height is 3. Okay? So if you notice though, I ended up with the same thing over on this one over here. So let's do a separate one again. 60 inch cubed, and I'll do an easy one, 610 again. And I'm going to take this 10 this time, and I'm going to split it up to 10 times 1. So I end up with 6 times 10 times 1. So my length was 6, my width is 10, and my height is 1. Now you could guess, check, and revise. That would take you a long time, but this factor tree will help you a lot in the future. So remember this. So let's take the skill we just learned and put it into practice. It says Ren wants to build a box organizer scrapbook supplies. She has a stencil that is 12 inches wide and needs to lay flat in the bottom of a box. The box must also be no taller than 2 feet. Name one way that she could build a box with a volume of 72 cubic inches. All right, so we're going to start off with our 72 cubic inches. And if I look into 2 factors, I'm going to start off with this 12 inches wide, and I'm going to make that one of my factors. And I know the other one would be 6, because 12 times 6 equals 72. So right now I can see my width. I already have the 12 inches that it's looking for. Now I'm going to break the other factor apart into 2 times 3. So because now I have 12, 2, and 3. So 12 times 2 times 3, 2 times 3 is 6, 6 times 12 is 72. So it works. Now it says it has to be no taller than 2 feet. So height, I could put it 3 inches. That's not any taller than 2 feet. The width, is equal to 2 inches. So we've met all the requirements. I think this may be a typo here. I think this should have been, the box must be no taller than 2 inches. So if that was true, then I would just turn these two around to meet that requirement. And I would put this as 3, my width is 3 inches, my height is 2 inches in order to meet the restraints of the problem. Now it's possible you could come up with different answers than that. Okay. After all the organizing, Wren decides she also needs more storage for her soccer equipment. Her current storage box measures 1 foot by 2 feet by 2 feet. She realizes she needs to replace it with a box with 12 cubic feet of storage, so she doubles the width. Will she achieve her goal? Well, first off, let's take a look. It says 1 foot long, so length equals 1. Length equals 1 foot. Now the width is 2 feet, but it says she's going to double the width. So it was 2, so now we're going to make the width 4 feet and 2 feet high. So the height is going to remain 2. So they have 1 times 4 times 2, which 1 times 4 is 4, 4 times 2 is 8. So there's going to be 8 feet cubed. Now, according to questions, is that she needs, let's say, her current storage, she needs more storage for equipment. Her current storage box measures 1 foot by 2 feet by 2 feet. She realizes she needs to replace it with a box with 12 cubic feet of storage. Well, as you can see, she only has 8 cubic feet of storage. So she did not reach her goal. If she wants to keep the same height, keep the height the same, what could the other dimensions for a 12-foot cubic storage box? Okay, well, we want to start off with 12. Okay, and it says she wants to keep the height the same. So I'm going to look up here, and the height was 2 feet. So that means this one here is going to have to be 6 feet. And then when I go to these, I could go with a couple of them, but I'm just going to go with 2 and 3. So now the dimensions would be 2 by 2 by 3. This here being my height, my width, and my length. If she uses dimensions in part B, what is the area of the new storage box? Well, we can see this is 2 times 2 times 3, and now with feet, I'll put the feet marker on there. Well, 2 times 2 is 4. 4 times 3 equals 12 feet cubed. How has the area of the bottom of her storage box changed? Well, the bottom of her storage box, if you come up here, it said it was 2 feet wide. It stayed the same. Okay. Now, if I had swapped these around, I could have made it the length 3 feet and the width 2. Excuse me, width 3 feet and the length 2. But I didn't, so the area in the bottom, oh, it's the area of the bottom. How has it changed? Well, if we come up to here, you see it was 2 feet by 1 foot. So the area initially was 1 foot times 2 feet, which equals 3 feet squared. Now, as you can see, we have length, which is 3 feet, times width, which was 2 feet, so that equals 6 feet squared. So the area doubled.